That's how you know it's a mixture. If it's not on the periodic table, it cannot be an element. Well, first of all, they're what we call pure substances. And the first one is an element. So an element is just one type of atom. I have a couple listed here: sodium, oxygen, that's the oxygen gas that you're breathing right now, hydrogen, magnesium, and chlorine gas. So notice some of them have two atoms together, like oxygen. That means that it is still an element, even though there are two atoms bonded together, they're the same type of atom. Now, what is a compound? A compound is where you have two or more different types of atoms bonded together. So, in fact, you can take two gases like oxygen and hydrogen, bond them together, and get something totally different. And that is the compound of water. Notice that water is always two hydrogens to one oxygen, and that is a fixed ratio. Compounds have a fixed ratio. I'll write that down for you. All right, and then sodium chloride, you know that's table salt. Sodium and chlorine bonded together gives you sodium chloride. Those are examples of compounds. So two types of pure substances. Elements. Where do you find elements? Elements are on the periodic table. And you probably have a table handy or one in your classroom, etc. If it's not on the periodic table, it cannot be an element. So make sure you keep one handy. Just because you've heard of something doesn't mean it's an element. You have to actually look for it. So elements are always listed on the periodic table, and there aren't that many, right? So there aren't that many elements that were created, but they're all listed there for you. Now, the last thing is, in fact, how most substances occur in nature, and that is as a mixture. A mixture is when you have two or more compounds or elements mixed together, just what you think. And they can be made at different ratios, okay? Remember how I said compounds are at a fixed ratio, but a mixture can be made of different ratios. For example, dirt. Is all dirt the same? Some dirt may have a little more clay in it. Some dirt may have more organic matter. You can make dirt with all kind of different ratios. That's how you know it's a mixture. Maybe lemonade. You can make it really sweet or really sour. You can use different ratios of those substances. Now, mixtures can be separated by physical means. And so let's talk about two types of mixture. One is what we call homogeneous, and that is where it is evenly distributed throughout. For example, the Powerade. It's a solution that is based on water, and we have a lot of different compounds dissolved in water, and it is evenly distributed. There aren't little chunks of salt in there and little bits of color floating around. It is distributed throughout. That's why we call it homogeneous. And then heterogeneous mixtures are not evenly distributed. And so I have an example there of salt and pepper. You can see little bits of salt and you can see little bits of pepper. In fact, you could very tediously go through and pull those apart. You could separate those based on those physical properties. Okay, so there's the difference in compounds and mixtures. Most things occur as mixtures. What are you? You're a mixture of thousands of different compounds. All right, how do you separate mixtures? These are just a couple ways, but it's based on physical properties. For example, filtration. If you have a solid and a liquid, maybe you made coffee this morning, you did filtration. You put a little coffee filter in there. Here's your coffee grounds. You're going to pour a little water over the top. You get a solution, and then what happens? You're going to separate the solids from the liquid, and so that's filtration. Evaporation, let's say we had a little dish of salt water and we let it sit out for a couple days. What would happen? Well, the water would evaporate, and what would be left on the bottom? Little crystals of salt. Okay, that's evaporation. Distillation is when we have a vessel and we use heat. Well, I'll put a little fire here. We've got a mixture of a bunch of different liquids, and we're going to separate them based on boiling point. So when this mixture reached the boiling point of one of those substances, it would come out. It would go into the gas phase, and we could get all of that off. And then maybe we would raise it to another temperature and get another substance off. So distillation separates mixtures based on boiling point. And then chromatography is something that you might have done in lab. I like to take a piece of paper, and then I get a drop of water-soluble ink on there, and then I dip it in a little bit of water, okay? And what happens is that water starts wicking up the paper, and it'll carry with it the different components of that dye, and it'll usually separate into, maybe you'll see a little line of yellow, and maybe you'll see a little line of the blue, and you can see some of the different components of that mixture that was homogeneous. So these are just a couple of examples of separating mixtures based on physical properties. But you already know how to do this, right? Have you ever ordered something, maybe a salad, and it came with something that you didn't like? How would you remove that? Well, you would separate it based on physical properties. I don't like tomatoes, so I say those red things, I'm going to remove them based on that physical characteristic. So I hope this helps. We are going to do a little quiz before we finish this video. So, can you identify these common substances as element, compound, or mixture? So, air. What is that? Well, it's not on the periodic table, so it can't be an element. And is all air the same? Or could air vary in composition? Yes, it could. So that means that air is a mixture. Okay, now the next one, I see magnesium and I see chlorine atoms bonded together, two types of atoms bonded together. So that is a compound. And then the next one, I see two atoms bonded together, but they're the same element, same type of atom. So that is an element. That is oxygen gas that you are breathing now, and that is on the periodic table. And then tap water, what is that? Well, is all tap water the same, or could it vary in composition? Yes, it could. Maybe you travel and you go to a different city and you say, oh, this water tastes really different than where I live. So tap water contains different things dissolved in it, and that's what gives it the different taste. So I hope this helps you determine if something is an element, a compound, or a mixture.